All right, let's get right into it. We talk a whole lot about developer productivity, but how do we actually measure the human cost of writing code? I mean, what if I told you the secret to understanding developer burnout didn't come from some startup in Silicon Valley, but from a mission control center at NASA?
So here's where the problem really starts. Check out this number. A recent report found that almost 45%, that's nearly half of organizations, have zero metrics in place to track if their platforms are even successful. That's a massive blind spot, right? We're building all these complex systems for our developers, but we're basically flying blind when it comes to understanding their actual impact.
And it gets worse. For the companies that are measuring something, a lot of them are tracking the totally wrong things. See, when you focus only on output, things like deployment frequency or lead time, you can accidentally create a really toxic environment. We push for more speed, more velocity, but we never stop to measure the human cost of it all. And the result? Well, it's exactly what you'd expect. Burnout, more mistakes, and your best people heading for the door.
And that brings us to the absolute core of the issue, this huge measurement blind spot. We've got plenty of tools to track what our teams are producing. What we're missing, though, is a way to understand the effort, the friction, the sheer mental gymnastics required to get that work done.
And that invisible effort? It has a name: cognitive load. The easiest way to think about it is like the RAM in your computer, but for your brain. It's the amount of mental horsepower you're using at any given moment to juggle a task. And when that load gets too high, your ability to learn, to solve problems, and to write good code just tanks. This isn't some small thing, it's a fundamental bottleneck on performance.
And I'm willing to bet this list right here feels painfully familiar to a lot of you. This is the daily grind for so many developers, drowning in endless YAML files, bouncing between a dozen different tools just to do one simple thing, or constantly putting out fires instead of, actually building cool stuff. These aren't just minor annoyances. They are bright red warning signs of dangerously high cognitive load.
So the big question is, how on earth do you measure something as fuzzy as mental effort? Well, the answer, pretty amazingly, comes from NASA. Yep, an organization where understanding human performance under extreme pressure isn't just a nice-to-have, it is literally mission critical.
Meet the NASA Task Load Index, or TLX for short. This thing is basically the gold standard for measuring how much workload someone feels. And it's not just for astronauts. It's used to figure out the cognitive strain on surgeons in the middle of an operation, on pilots landing a plane, and even on operators in nuclear power plants. We're talking about fields where the cost of mental overload can be, well, catastrophic. And look, this isn't some brand new, unproven idea. The TLX was developed way back in the 1980s. It's been rigorously tested and validated with thousands of data points and cited in thousands of research papers. So the key takeaway here is, this framework is legit. It's built on a rock-solid scientific foundation.
So how does it actually work? This is the brilliant part. Instead of just asking a simple question like, how hard was that? The NASA TLX breaks down that subjective feeling of workload into 6 separate, measurable dimensions. This is what gives it its incredible diagnostic power.
First up, we have mental demand. This one's pretty straightforward. It's the pure brain power. How much thinking, calculating, or remembering did you have to do? Was it a simple automatic task, or was it incredibly complex? Second is physical demand. And you might be thinking, physical? We're developers, we sit at desks. But for a dev, this isn't about lifting heavy boxes. It's about things like the strain of clicking through a dozen confusing UI screens, or all the extra typing you have to do to wrestle with a clunky command line tool. Third, there's temporal demand. This is all about the time crunch. How hurried or rushed did you feel? This is super relevant when you're dealing with something like a production outage or trying to push a critical bug fix.
Number 4 is performance. Now, this one is all about your own self-assessment. Forget the actual outcome for a second. How successful did you feel? Did you feel like you totally nailed it, or did you feel like you just barely managed to get it done? Okay, the 5th dimension, effort, is a really subtle but super important one. It separates the work you put in from the final result. Think of it this way. You might have felt really successful in the end, but did you have to run a mental marathon and absolutely exhaust yourself to get there? And finally, the 6th dimension, frustration. Ah yes, the one we can all relate to. This measures the emotional toll. How annoying, how stressful, or how discouraging was the task? This is a direct pipeline into the things that cause serious burnout. So we've got these 6 dimensions that were originally designed for pilots and people in mission control. But the real magic, the aha moment, happens when we take this exact framework and map it directly onto the world of software development.
And this table here just nails the connection. Just look at that last row. A high frustration score isn't just someone having a bad day, it could be the direct result of terrible error logs that keep blocking their pipeline. High mental demand isn't just a tough problem, it's the direct result of trying to debug a mess of undocumented microservices. All of a sudden, those subjective complaints become objective, diagnostic data you can actually use.
And this all leads to a really fundamental shift in how we should be thinking about engineering metrics. It's about moving away from just measuring the final output and starting to diagnose the human experience that actually creates that output in the first place.
Look, things like DORA metrics are fantastic. They tell you what happened. Your lead time went up, your change failure rate spiked, but they almost never tell you why. The NASA TLX framework gives you that missing diagnostic layer. It helps you understand the human friction, the sky-high mental demand, the intense frustration that's causing those output metrics to suffer.
So why does all this matter? Well, because diagnosing friction is a complete game changer. It turns those vague feelings of, "this is hard," into cold, hard data. It lets you pinpoint the exact source of a developer's pain, which means you can finally justify spending money on better tools or better documentation. Ultimately, it helps you build a truly sustainable, high-performing engineering culture that doesn't just burn people out in the name of velocity.
So I'll just leave you with this one question to think about for your own teams. Are you measuring the friction your developers face every single day, or are you just measuring the speed at which they're forced to overcome it? Because the answer to that question could be the difference between an engineering org that just gets by and one that truly thrives.